Okay, let's look at the derivative of the natural exponential function. So we're going to look at the simple rule. Okay, so we start with the function e to the x right here. And the derivative of e to the x is just e to the x. So for an exponential function with base e, the derivative is the same as the original function. In general, if I want to look at the generalized rule for the derivative, so d dx means the derivative of e to g of x. So this means that I'm going to have some sort of function as the exponent. So I might be looking at, say, something like e to the 3x plus 5, or e to the x squared minus 4. So the exponent is itself a function of x. So we call that g of x. Okay? Then the general rule is e to the gx times g prime of x. So notice that this part stays the same as the original function. So that gets copied over. But then we multiply by the derivative of the exponent part. Okay? Sometimes we can just, because it's multiplication, we can reverse them. We can write as g prime x e to the g of x. So either format is fine. This last one is often more convenient just for writing the algebra in a convenient way. Okay, so let's apply this rule with some examples. Okay, so we're going to go through the example 3. All right, so part A, our function is 2e to the x. Okay, so we have the exponential rule says that if the function is e to the x, the derivative is e to the x. So if you take the derivative of e to the x, we get e to the x. Okay, so this 2 just stays there. I take the derivative of e to the x and I get e to the x. Okay, so this is the answer for this. We're done. So we copy the function over, and then we multiply by the derivative of the exponent. Okay, so in this case, the derivative exponent is just 1, so we don't write it. Okay, so we follow this general rule right here. This is a specialized rule. When we have the exponent is just x, then that derivative g prime just turns out to be 1. So that's why we don't see it, because it's times 1. All right, let's look at B. Okay, so we have 2 terms. Each of them is an exponential. So this one, we have e to the x. We copy down the function. We multiply by the derivative of the exponent, which is just 1, so we don't write it. Second one, e to the 2x, we copy down the function. Then we multiply by the derivative of the exponent. So we take the derivative of 2x prime. This is just 2. So this 2 gets put in front. Okay, so we copy down the exponential, multiply by the derivative of the exponent. Okay, so this is the answer for B. All right, let's look at C. We have 3 terms. We have one that's x squared. So this one we need the power rule that we saw in the last section. This is e to the x, so we need the exponential rule. All right, and this is 2 over x. So this is not in the correct format. We want to rewrite this as 2 to the x minus 1. All right, so we have stuff on the bottom. You want to rewrite it as a negative exponent. And then we use the power rule on this too, because it's x to the something. Okay, so let's work through these term by term. So the first one with the power rule, the 2 comes down and multiplies the 2 in front. We get 4x. And then we subtract 1 from the exponent. 2 minus 1 is 1. All right, minus the exponent rule says copy down the exponent, e to the x, multiplied by the derivative of the exponent. Derivative of x is just 1. I could write it in front, but multiplying by 1 doesn't change anything. All right. Then the last one, this one, we apply the power rule because it's x to a power. So the negative 1 comes in front, multiplies the 2. So that actually turns into minus. So minus 2x, subtract the 1, negative 1 minus 1 is negative 2. Okay, so we have the answer there. You can see that we used 2 power rules and 1 exponential rule. Okay, so we want to be able to recognize which rule we need to use, right? So for terms that you have x to the n, we use the power rule, which is n x to the n minus 1. For things that are e to the function, we use the exponential rule, which says copy down the original and then multiply it by the derivative of the exponent. All right, so the next one, part D. Okay, so D, we have 2 terms. This one is a constant, so the derivative is 0. Minus. This one is an exponential, so we follow the exponential rule, which says copy down the exponential just the way it is, then multiply by the derivative of the exponent. So we need to multiply by the derivative, the prime of x cubed, which is 3x squared. So this 3x squared goes here. So you copy down, you multiply by the derivative of the exponent. So we get negative 3x squared e to the x cubed. All right, let's look at e. So e is an exponent. We use the exponent rule, which says copy it down just the way it is, multiply by the derivative of the exponent, which is 2x. We're done. All right, so this was the original function. This is the g prime. This is e to the g of x. We started with e to the g of x. So we have e to a function, derivative, you copy down e to that function multiplied by g prime, which is the derivative of the exponent. Okay, next one. 5e to the negative 2x, exponential rule. I have the 5 e to the negative 2x. So notice I just copied down the original function, I left a gap there so I can take g prime. So this is the exponent. I'm going to take the prime of that. We get negative 2. So fill the gap with that negative 2. Okay, then we can multiply 5 times negative 2. We get negative 10 e to the negative 2x. Okay, let's look at this one. This is another exponential. So I have the 2. So we copy down exactly as it is. The original problem gets copied down, the 2 and the e to the 2x. And then in this gap here, we multiply by the derivative of 2x minus 1, which is 2. Okay, so we get 4 e to the 2x minus 1. Okay. All right, let's look at this one. So this has 2 terms. This one is a power of x. So we need the power rule right here. This one, the next one is an exponential. So we need the exponential rule right here. All right, so let's do the power rule. We have the 2 times the negative 3 gets me negative 6. Subtract 1 from the exponent, we get x to the negative 4. Okay. On to the exponential part. We're going to copy this down exactly. We have 5 e to the negative 3x plus 1. Okay, I left a gap there because I'm going to fill it in with the derivative of the exponent. Derivative of negative 3x plus 1 is negative 3. Okay, so we have negative 6x to the minus 4 minus 15 e to the negative 3x plus 1. Like this. Okay.